All right, folks, let's talk lists. So this is just the basics of lists. A list is a container. So I'm starting with what's a list, right? So a list is a container for multiple pieces of information. It is ordered, and by that I mean that it's numbered, right? So if I'm going to get something out, I'm going to get it out by which number thing it is in the list. And it is a variable size. Okay, so that's the basics. I'm going to show you how to make one right off the bat because I think it'll work better if we have an example. So let me make one called numbers. And the way you make a new list is you just name the variable that you're going to put it in, and then you put square brackets, and then you can put in whatever you want. So I just comma separated this list of numbers. If I want to print it out, so if I want to if I want to print a list out, I do print and then just the list's name. So it's numbers. I print it. I'm seeing one square set of brackets and then all the things in it. Notice that it prints out with a space separating things. I didn't put those spaces in there. That's just a formatting thing. Okay, so I've got my list initialized. Right? That's what this line is doing. It's declaring and initializing my list. Then let's see what else we can do with this thing. So I'd like to be able to do some operations with lists. And the first one, the one that you're going to want to do all the time, is you're going to realize that you've forgotten something or that you've made a new thing and you need to add it to the list. So the easiest way to do that is to do numbers dot and append is the right thing here. And so the thing I want to append is, say, the number 10. So now if I run this, if I run this, it's not going to change the output because it's printing the list of numbers first before it appends, right? Okay, so let me maybe do a little formatted string here. So the new list is now numbers. Okay, so there's my list with my number 10 at the end of it. That's how you add things. So that's adding it to the end. Okay, so let me add an item in a specific slot. So I do need one thing that is just a little bit counterintuitive for people. So in my list here, I have this number 1. That number 1 is in the first slot, right? Unfortunately for the human brain, computer science counts in kind of a funny way. So there's the 0th slot, the first slot, the second slot, the third slot. And so you're going to hear me refer to that first slot as either the first slot or the 0th slot. I'm going to do that interchangeably, and I'm sorry. It's just because that's how my brain works. It is the 0 index slot, and I am oftentimes going to call it the first slot. So this is bad, terrible habit on my part. I'm trying to break myself of it. I'm trying to refer to it as the 0th slot all the time. But I'm not terribly good at it yet. So if you catch me saying the first slot, I'm probably referring to the index 0 slot. So if I want to add an item in a specific slot, I'm going to try to insert something right into this slot here, which is the number 1 slot, because 1's in the 0 slot, so 2's in the 1 slot. So I'm going to do numbers dot insert, and then it says index object. So at slot 1, I'm going to insert, and I'm going to make it really obvious that it's different. So I'm going to insert a string that says Bill. Oops. And now, again, my output's not changing because I didn't print it again. Okay, so now you're probably noticing that I had a list of numbers and I just stuffed a string in it. And Python doesn't care. It's going to very happily let you do that. That'll have some advantages for us in the long run, but for right now, it is a bit frustrating. So I'm going to add that to my list of things describing what a list is. And one thing a list is ungiving of F's about the type of variable or information stored. So there are no F's given by the list about which kind of thing you're sticking into them. So append puts things at the end. Insert puts things into a specific spot. It should be noted that there are some challenges. So if I make a list called new numbers, and I say that's equal to numbers. Now, it seems like new numbers should be a copy of numbers, right? And so I should be able to have that original list here. Right. So I'm going to print out the new numbers list. Oops, I guess I shouldn't have called it new numbers. Let me call it old numbers. How about that? Because I'm changing it. So if I want to print out a string saying the old numbers list is, oops, those are the wrong bracket. Okay, now that's a bit confusing, right? So you'll notice here, I said that the numbers list was 1 through 7, missing 4, and then the old numbers was just a copy of that. But as it turns out, when I change the numbers list, the old numbers list changes too. And the issue there is that a list isn't passed when you do this. It's not a copy. It's pointing at the same place in the memory in the computer. And so when you change one, you change the other one. So if you want to keep a copy, you need to tell it to get a copy. So you need to use the copy method here. And I'm diving down a little bit of a rabbit hole here. I'm just going to pretend that I said the word function, but it's actually a method. So use the copy method to copy a list. If you don't, you'll just have 2 names for the same list. You guys see that? And having 2 names for it is not an advantage most of the time. So, print out the whole list. Okay, so couple of more things, more items. One item you're gonna want to, or one operation you're probably gonna want to do eventually is you're gonna want to clear a list or erase all the items. Okay, so if you want to erase all the items, you do numbers dot clear. And then let's print out our, oops, I guess I should take my comment too. And now it's empty. So clear is the method to remove everything. There's a delete method and a pop method that are also available. Oops, let's not do those there. Let's try the delete method first. So let's do numbers and, oops, I don't know why I wrote it that way. Let's do numbers dot, oh, okay. So I have pop and remove are options. So let me try remove first. So let's say I want to remove Bill. And I guess I should use the right word here. So let's remove the Bill entry. Oops, and again, we need to print it out. Okay, so we put Bill in, and then we removed it, and then we cleared it, and then we printed the original. Okay, so that's how you remove something by value. Do be just a little bit concerned here. If you have multiple copies of a number in here, and you go ahead and try to delete, if you delete them, you will notice that it just deleted one of them. So if there's multiple copies, the remove method will just remove one of them. Okay. Next item up for grabs. Let me set this back to Bill here. Since my comment said I was removing Bill, I should actually remove Bill. Yeah, do please, you know, if you change the code, you should probably change the comment that goes with it if the comment's specific to the code. It is very confusing if the comments are old and they go with a previous version of the code. So try to keep the comments up to date as you're rolling through. If you want to do this other method of pop, so let's look at the information for pop. Oops. Pop. Come on, where'd my little info pane go? Oh, well, that's not very useful. Okay, so if I run pop, oops, we still need to print it out. Okay, if we run pop, we notice that the last thing goes, or you can give it a place and it'll then remove the thing in that place. You can feed it a range of places and some other stuff, but let me just go with the idea that pop right now is the kind of right item. So that's how you remove a thing. And again, this is the 0 slot, so it removed 1 because 1 is in the 0 slot in that list. I'm also going to stumble over the difference between a list and an array here. The difference here is that Python doesn't actually have arrays. Other languages have arrays. Sometimes they resemble Python lists, sometimes they don't. Most often, they are ordered in the same way, but they often care about the type of information that's stored, and they also are often a static size. Lists are not a static size, which makes them very much more convenient in my eyes, at least. Oh, good point. If we want to know how long the list is, so let me print out a formatted string saying the numbers list has things in it. And how many things has it in it? Well, it has len of numbers. And so that len returns the number of items in a container. And in this case, a list is a container, right? It's a container for multiple pieces of information. In the same way that a string is a container for letters. The numbers list has 0 things in it. Oh, because I cleared it on the line beforehand. So if I throw that in a couple other spots here, like right here and right here, we'll see that we had a list with 9 things in it. 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be noted, by the way, that there is no 9th thing in this list, because again, they start counting at 0. So this slot here that contains 10 is the 8 slot. And then we notice that after we remove a thing, we get a list with 1 shorter, and then when we clear it, actually that's a pop. I'm sorry. We popped 1 thing off the list, right? And then our list is 1 thing shorter, and then we cleared it, and now it has no things in it. So those are good for some kind of diagnostics. It is best not to hard code the length of a list. So we're not gonna ever usually write a number in the code for how long a list is. We're always going to use the length function to get that number, or we're going to use some more varsity methods. But don't assume that lists are statically sized ever, because they're just not. That's one of their major advantages here, actually. Okay, so this is basics on lists. If you need more stuff, the W3 Schools has some nice explanations of more methods. Oh, and I keep saying the word method instead of functions. If you're not familiar, or this is your first programming class, you can shut your brain off right now. I'll give you a second to do that. Okay, for those of you who are interested, the difference between a function and a method is that a function is not a part of an object. And in this case, the methods that we're talking about are part of the list object class. So I have a list class, and then I have a copy function, right? Except this is actually a function in an object, so this is a method that the object has. So anytime you have some kind of an object, and then you're calling dot and something, that thing is a method. And that's different than the length function, which is actually a true, honest function, because that thing takes an object as an argument, it's not a property of the object, it takes an object as an argument. That distinction is probably a bit much for most folks, but it's okay, we'll get to objects later.